Hello everyone. I am Madhumita Mantri, product lead at Startree. Startree is an early stage B2B startup building real-time analytics and anomaly detection solutions. And I'm super excited to talk about this topic, which is very interesting to me. And with the growing needs of AI, how we can safeguard AI outputs, boost R&D efforts by monitoring bias in AI. That's what I will be covering in this talk. So let's dive in. Today's focus is unmonitored AI is prone to bias, and that's a major danger. That is what I would be trying to articulate and in this talk, and covering different aspects of what is bias, what are the different types of bias, and how we can mitigate by monitoring and doing an anomaly detection. And I will also give a walkthrough of case study, and we'll wrap up with a few key takeaways. So let's dive into some of the stories of AI failures. To begin with, there are a bunch of AI failures I've listed on the slide. I'm not going to read for all of these, but something that stood out is IBM's Watson for oncology cancelled after $62 million. And this is all because of unsafe treatment recommendations. Similarly, another example, Apple's Face ID defeated by a 3D mask. And if you dive deep, it's pretty much the AI risk, unhandled AI risk that are causing these AI failures. And the AI failures not only happens here, it spans across chatbots with the ChatGPT coming in. If your LLM is getting having bias or having any kind of unexpected inputs going into the AI, then the LLM is no longer bias free. It's no longer fair enough. And there are multiple other things might be going with political angle, autonomous driving, facial recognition, and many more, where there are multiple AI failures because unhandled risk, and most of the risk are usually due to bias in AI. So that's what I will be focusing today. Now, the topic of discussion today is safeguarding AI output by monitoring bias. So bias could happen any stage, anywhere, data, algorithm, ecosystem. My focus for today will be how to safeguard the AI output when it comes to the algorithm, and how we can do that by monitoring bias. So here is an introduction to AI bias. What is AI bias? Well, creating algorithm that operate equitably across all demographics is something called bias free. And if there is a bias, that means we are not able to produce equitable outcomes across all demographics. Why does it matter? Well, fair models, which is bias free, foster trust and regulatory compliance, impacting user satisfaction and business success. Or every models or AI algorithms or systems, they start with initially bias-free zone, and they change over time, and bias can be introduced because of data changes or societal contexts evolve. Today, my focus will be more centered around the data, and we'll see how bias can be monitored. Here are different types of bias. One is demographic parity. A good example of this is if you're targeting users of different genders, and it's a promotional ad that you're targeting, and you might be introducing bias there, and recommending wrong thing for wrong, incorrect gender. Equal opportunity is another one where applying for jobs, if there is a job matching based on the ethnic, gender, race, then if there is unequal positive rates for during the matching process, that means there is bias. Predictive equality, which means there are a bunch of race or income groups while applying for loans. In the loan approval, higher positive rates for a specific income group versus the other. And this is where the predictive equality goes wrong. And this might be happening with some kind of bias underlying. And the AI models are no longer fair enough. Contextual bias is another big element where societal and business context come into play. Where, for example, you are building a skincare product and recommending skincare product to different gender, like male versus female. And if there is a bias or the model is not fair enough, then it might be giving an incorrect treatment recommendation for a specific gender and age group. So, what are the different AI bias risk where it can be introduced? Biased data sets can result in biased algorithms, and biased algorithm use of that by applying societal context amplifies the impact further. It results in inaccurate predictions, discriminatory predictions and outputs. And as a result, you see loss of customer trust. Your brand reputation is jeopardized. There is regulatory scrutiny. Employee trust gets impacted, and many more. And end result is most of the time people are losing faith in their product or things that they are building, and also monetary loss, productivity loss, and likewise, there's many losses that occur. Good examples are unfair loan denials, biased criminal sentencing, discrimination in hiring, unequal access to healthcare, and things like that. So now, what is the root cause of this algorithmic bias? There are types of bias: data, model, and interpretation. So bias can enter different stages. Data, when you are collecting the data, and if your data points are biased, then you are feeding like the data generated from it or insights generated from it will be biased. And when you blend it with the historical data, it causes inequities. There's also human discretion that happens once you get this data, and there's a human labeler who is labeling the data, can also introduce bias, like unrepresentative society, say, is training your models or labeling your models. Likewise, real world examples I've already covered, so I will not go through again. Now, if bias is not tracked well, the risk we already saw, that is external risk. Now, if we flip back and look at internally what is going within a company who are developing these products, who are experiencing bias in AI predictions and AI models. Now, the AI ecosystem has these key players, and obviously, there's a chaos going on when bias get introduced. Why is the model drifting? Is the time to retrain the model? What are the limitations? Are we using right data? Can I trust this prediction? And likewise, and is this a spam model? Is safe to use? Multiple questions are coming, and it's a completely chaotic environment. And so what's the solution? Well, focus on metrics that matter, monitor the fairness of your models, eliminate bias, and take necessary actions. And all these need to happen in real time to reduce the chaos, reduce productivity loss, reduce revenue loss, and most importantly, build a reliable and trustworthy system. So what different types of metrics we can measure? Like here is a good example I've highlighted is ratio of favorable outcomes across different groups. This is a time series based metric. If you monitor over a period of time, if there's a spike or a gradual change, for in a specific group, you identify and take quicker action. Identify the root cause, of course, what is contributing to this unfavorable outcomes across different groups, and what actions you can take to eliminate bias and have a fair model and safeguard your AI outputs. So now, obviously, if you start monitoring, you detected an outlier, and the outlier could be caused by imbalance feature distribution, complexity in selecting metrics, data driven. So, mm, taking a data driven approach, you can find those insights, actionable insights. Now you can take a necessary action accordingly. Imbalance feature distribution means your feature training might have issues, or the data you are collecting is underfitting or overfitting, and things like that. Now, let's dive into if you are building a monitoring and anomaly detection system, because that's going to help eliminate bias. So, if you're doing that, then what are the common challenges you will encounter? Well, if you are targeting an incorrect gender, and that means your marketing has a bias, and once marketing is biased, it generates biased data because the response is going to be biased as well, and it will again, it's a feedback loop, so it will result in unfair recommendations. So peel the onion behind the scene. What happens? There's a model which is acting behind the scene. It is analyzing supposedly this biased data and generating insights, which is again biased insights, and enabling decision makers to make some decisions based on the data, but data is biased, so your decision quality degrades, your experimental velocity degrades to do multiple experiments if you're part of an R&D group, and the impact multiplies likewise if you have a bias in your AI data. So it's extremely important to safeguard these AI outputs. Now since we are talking about model and taking a data-driven approach, where exactly we need to monitor this bias and making sure the model is fair enough. Now, the bias can be introduced anywhere, any stage of this model life cycle, starting with collecting the data, training the model, deploying the model, and post-deployment as well. I will show both the aspects of deploying the model and then post-deployment, how you can monitor bias and how you can also monitor bias during A/B testing, and to make sure the bias-free model is there, or fair AI model is delivered end of it. And also it remains, not only it starts with bias-free model, but it remains bias-free as the data grows or societal context changes. So pre-deployment AI model, this A/B testing happens. And as a part of that, you can introduce, while A/B testing is happening, you are experimenting, you can introduce an anomaly detection monitoring process in that, like that is continuous monitoring. And when anomaly detected, you trigger an alert and say there is fairness experts or AI risk experts. They look into it and they confirm if this is a bias versus not, and then you can do model refinement and proceed to model deployment. So that's what something you can do pre-deployment stage. During AI model A/B testing, if we dive deeper, there are multiple things you can monitor. Like you begin with a hypothesis formulation, this random assignment of control and variable happening. So data-wise, if you monitor both control and variable and see how the AI outputs are changing based on certain parameter, as an example, safety, toxicity, bias, PII data, tone, prompt injections, if they are all like biased, these are the things you can compare between your control versus variable. So control is always existing, so your model starts with bias free. But as the model changes or there are experimentations happening, that's the variable component. If that is introducing bias, comparing the two, you will know during A/B testing itself, and then you can mitigate. This gives a experimental boost and velocity boost, and you can safeguard AI outputs. Now, post deployment, once the AI is deployed, you can also define and prioritize fairness metrics. You can monitor them, and you can identify root cause behind these issues. So, monitor means you need to monitor specific outcomes of your AI. That is, say, for example, how many loan approvals are happening, or what is the fairness score look like? Is this fairness score a steady state? The false positive rates have been steady state, or it is spiking up or decreasing, and things like that you can monitor. And then there is a continuous feedback loop you can introduce to make sure your AI remains fair as the data changes and societal context changes post deployment. Now, what are the growing challenges with this monitoring and anomaly detection solution? Doing a real-time detection is very important, especially with high dimensionality and complex data. And use of adaptive algorithms is important because data pattern is changing, metrics is changing, and there are multiple things are changing around the ecosystem. So an adaptive algorithm is very much necessary. Even though you have an adaptive algorithm, there could be alert fatigue. So you need to consider if you are building a robust in monitoring system that is generating more true positive based on your context. And doing this in real time definitely boosts the number of true positives as compared to false negative because you are training the data in live. Now, explainability, once you detect the anomaly, what is going wrong? Like, where is it going wrong? Is it a global level, local level, or cohort level? I think these are the part you can monitor. Cost of operations and computational expensiveness, if the model is complex and the data stream is large, that's another big thing you can look at. Now, let's dive into the case study. So before diving into the case study, in the case study, the samples or examples that I'm using, I'll showcase how you can do that using Third Eye, which is a product by Strategy, and it does real-time monitoring and anomaly detection on large and complex time series data, fast tracks problem solving, and that kind of helps, and has adaptive algorithm running detection on live data with a great amount of explainability and reduced OpEx definitely helps with automated monitoring and detection. It's powered by Apache Pinot, making things more data-driven, confidence in near real time. Now, the case study, in the first case study I will be covering is AI fairness in loan approval, potential racial bias in AI-powered loan approval can result in unfair recommendations. So the solution is during A/B testing, as I was explaining, monitor control versus variable and monitor the approval rates during this phase and see if there is bias getting introduced. There's a sudden drop or a spike or gradual change over a specific ethnic group in the control group versus variable group, then you can identify those and take necessary action. In this example, I'm saying there's a credit score chain that contributed to this, and I was able to detect that and take the necessary action. So the baseline metrics I'm monitoring approval rate among by race. So I'm monitoring at a more dimension level granularity and correlating with credit score changes and then confirming if this is happening because of that. That means there's a bias getting introduced with respect to how we are doing the credit scoring across different ethnic groups. So this is the demo. Like if you can see, Third Eye is able to detect monitoring this time series data at a different granularity by applicant race. And then as an anomaly occurs, it is notifying the user, showing a heat map across different demographic and dimensions, so how the things are changing. As you can see in this example, suddenly there's a spike on credit score, and then the variable group has a spike in terms of number of approvals. So something really going wrong here in case you're incorrectly approving loan approvals. Then you're diving deep into looking at what is the root cause, and then you are able to tell, like, because of the credit score change, something going wrong. Now let me go and verify credit score and correct it. So that's the actionable insight. So the next one is the case study of, you can similarly do fairness score monitoring post deployment. So what is fairness score? Well, it's a report card that is given to an algorithm that is making decisions about different groups and people. And that is the score you can monitor. If there's a spike suddenly at a given point of time, then you're trying to identify potential causes. In this example, I'm considering human in the loop. In the right hand side, if you see the image, that's an AI generated image, has an incorrect spelling, doesn't look like English. Maybe the human in the loop who were converting text to image and having the text in place might be doing more of Hispanic people or Spanish talking people are there. So English is like getting mixed up and in poor quality result you see. So there's a bias and that is resulting in this. So the investigation kind of will get you to this result, whether the bias is introduced by a human or data and things like that. So in this example, same thing, we are monitoring across different demographic indicators. I'm using a synthetic data, so you don't see the real data names, but it is also, then you do a root cause, because it's automated detection. It is able to tell you which hour the demographic indicator spiked up, the fairness score spiked up, and why it is getting spiked up. That's what you are looking at. So you can then correlate with any of the external or internal event to tell what could have introduced bias. So if human in the loop is labeling the data and there's an activity happening around the same time, then you can pinpoint that the bias is introduced by that. Now, the key takeaways from this is real-time monitoring and anomaly detection are crucial for identifying and addressing fairness issues and keeping your AI bias free. There's proactive intervention can significantly improve your fairness and equity of AI-driven decisions. Transparency is extremely important, and definitely algorithm bias is threat to fairness and equity and can result in AI failures. So there's a continuous evaluation, improvement of AI models are required with ethical consideration. Human in the loop has a diverse group of people looking at it, and contextual understanding is there. So this bias is eliminated. So this is how you can safeguard AI outputs with anomaly detection and real-time monitoring. Thank you for listening to this talk. And if you're interested to learn about Third Eye or start Third Eye or joining